Welcome back, everyone. This is the continuation of our previous four videos on singly linked lists, traversal, and insertion. In this video, we're going to see singly linked list deletion, and under singly linked list deletion, we have three more cases: deleting the first node, deleting the last node, and deleting the intermediate node, which is neither first nor last. So for doing this process, first of all, whenever we say the first node basically means the node which is currently being pointed by start. So whichever node is currently being pointed by start is the first node. So to make this to remove this particular node, the easiest step could be just make this start point to the next node. That could be the easiest step to do. So we can call this statement as start is equal to start next. Okay, let us say this could be the minimum thing for removal of the first node of linked list. If you can write this particular statement, that means you have already performed the removal of the first statement. Let us see it practically in a compiler. Okay, so we are here in code blocks, and this is the program that we have just seen. I'm calling the function of this removal of the first node as remove first, and I have written this statement that we have just seen in the PPT. So here we are saying that start is pointing to the next of start, and I have already shown you what it will be pointing to. So let us go to a test program. In my main function, I have inserted four elements: one using the inserted beginning, two using inserted end, and one using inserted position. I have inserted four elements, and then I am displaying this element. For now, we don't need this. And after displaying these four elements, I am calling this remove first function. So basically, I'm removing the first element. I'm printing a new line just to make sure that there is a gap between this display and this display. Let us see what output we get. Okay, as you can see here, the first display has given me 4, 8, 15, and 7. These four elements were inserted here, and then as you can see, 4 is the first element. Even in this display, 4 is the first element, and then after this display function is called, I'm calling this a remove first function. So basically the first element should get deleted, and then after I'm printing a new line, and then I'm displaying the contents of the list once again. And as you can see, there is no 4 in the list, so the 4 which was the first element of the list got removed from the list. So as we have seen in the previous presentation, this statement is a valid way of writing your code for removal of the first node of the list. But why do we have two steps mentioned here? The reason we have two steps mentioned here is that if we just point this start to the next element, then even though this node is not currently being pointed by any particular pointer with which we can access this node, but the memory of this node is still consumed in the in our primary memory. So basically the memory allocated to this node is not removed yet, and because this memory allocation is not removed yet, this will be consuming memory. And uh, if you keep on adding more elements to the list, and if you keep on storing more and more memory, and if you don't deallocate that memory, that will create a problem in long term. And that is the main reason why we need to remove the memory. That means we have to deallocate the memory allocated for this particular node, which is not part of the list, and so which is of not much use once that particular node is removed from the list. And to achieve that purpose, we follow these two steps to remove a particular node from the linked list, as well as deallocate the removed node's memory. So for that, the first step tells create a temporary node which will point to the same node as that of start. So we have to create a temporary variable which points to the same node which is currently being pointed by start. And then the second step is move the start node's pointer to the next node and dispose the temporary memory. So we have to make this start move to the next node. All we have to do is make this start point to the next node, and that is what we can see here. Now start is pointing to the next node, and once we have moved the start to the next node, we have to dispose this memory. Basically, we are deallocating the memory allocated to this particular node using this temp. Unless otherwise we give a separate name to this memory block, we can't access this memory block, and so we cannot deallocate it. And that is the main reason why we have the first step as creating a temporary node point to the first element which we want to remove from the list. So let us try the same concept here in our function. Let us create a temporary node of my list node. I'm calling it temp. Sorry, temp. And then I have to assign that temp to the node which is currently pointed by start. So I'm saying temp equal to start. Those were the two steps. And then I'm moving start to the next node. And once that is complete, I have to deallocate the memory. I have to deallocate the memory of first node. So for that, there is a function called free. It is a predefined function available in C library, and in that I have to pass a pointer which is pointing to the memory which I want to deallocate. So currently temp is pointing to the memory block which we want to remove. So I'm calling this free function which will deallocate the memory. So the steps that we have seen are: first step is create a temporary pointer, make it point to start, then the continuation of the previous step. Sorry, this is the second step, which tells move start to the next node or element, and the continuation of that is and deallocate the memory of the first node, or dispose the first node's memory. So these are the two steps. So let us, though you won't see any difference even if you add these extra steps in the code, you won't see any difference in the execution of the program. Let us just check. We are not changing anything here, just to make sure that you compare the result of this one and the result of the previous code where we did not have any of these steps added, where we had only one statement in the program. So let us test it. And as you can see, there is no difference in the output. So though you don't see any difference in the output, but internally what's happening here, in especially for this particular statement, is the memory that is allocated to the first node is getting removed, so that that memory is now available for insertion of new nodes. So this becomes the complete code of the function called remove first. Thank you.